So remember, Chapter 2 definition, combustion air is air for fuel combustion, draft, hood, dilution, and ventilation of the equipment enclosure. We talked about the single purpose for Chapter 7 combustion air is to avoid the production of carbon monoxide. I want to be sure I have enough air to burn the fuel, and I want to be sure I have enough ventilation out of the room to where I don't re-burn that exhaust I just created, right? So that's combustion air. Page 85. Top left, 701 general. These are general requirements for combustion air. Down below that, 701.2, pressure difference. It says, where used, a draft hood or a barometric draft regulator shall be installed in the same room or enclosure as the appliance served so as to prevent any difference in pressure between the hood or regulator and the combustion air supply. All this means is, if your equipment has a draft hood or if your equipment has a barometric draft regulator, be sure and put it in the same room as the equipment it serves. All they're saying is, I don't want you to push or pull air to or from somewhere else. If this is my mechanical room, I have my fuel burning appliances in here, I'm going to size the combustion air for this room. So don't push air out, don't pull air in from somewhere else, right? If you got a draft hood or a barometric draft regulator, put it in the same room as the equipment it serves. We've already taken that into consideration now, right? I don't want you to push or pull air to or from somewhere else. All right, so look at me real quick. We're going to call this guy 701.4. We're going to call this guy 701.5. We're going to call the guy behind him 701.6. Now listen, I do this for a couple of reasons. First off, it's easy for us to tell these guys apart. I don't know anything about them, but I can tell they're different from each other, right? So 701.4, do you agree that's a rule? And 701.5 is going to be a completely different rule. And do you agree 701.6, whatever that is going to be a completely different rule again? Does that make sense? So let's back up. Let's talk about these one at a time. Tell me who this guy is, 701.4. He's going to tell me how to get my combustion air from where? Indoor. So look at me. That's this room right here. If I was writing the code, I would change that word indoor. I would change it to in room, just to be more specific. So this guy is going to tell me how big my room needs to be to get my combustion air from inside the room specifically. Okay? Now, we'll talk more about that, but before we do, let's talk about who is 701.5 real quick. Pay attention to the second word. Indoor what? Opening. So look at me. Do you agree the room's not big enough? So now we have to have an opening from the room to somewhere else that's inside the building. Does that make sense? So 701.4 was an indoor. That's just this room. 701.5 is an opening from this room to somewhere that is also indoors. One more time, who is 701.6? So, look at me. Do you agree one guy is indoor opening, one guy is outdoor opening? Do you agree I would never ever talk to both of those guys? I'm either going to give you an indoor opening, I'm going to follow his rules, or I'm going to give you an outdoor opening and I'm going to follow his rules. I'll never listen to both of them. Again, this is why I give these guys a different name and point them out, because we still have a tendency to read 701.4 and 701.5 and 701.6 when really only one of those are the rules we need to comply with. Now, I don't know if the code was smart enough to do this in this order on purpose, but I like the order they gave me, because if the room is big enough, do you agree I don't need to talk to either one of those guys about cutting holes? Make sense? So step down below there, highlight for me 701.4 and then 701.4.1. What is 701.4.1? Standard method to provide what?
The minimum required volume.
Indoor combustion air, right? To provide 701.4. It says the minimum required volume shall be 50 cubic foot per 1,000 BTUs per hour. So do you agree? This guy tells me, hey Wade, if you'll give me 50 cubic foot for every 1,000 BTUs you have, fire it up. Don't cut any holes anywhere. We're good to go. By the way, does this sound like something we've already talked about? Do you remember the definition of a confined space? Room or space having a volume less than 50 cubic foot per 1,000 BTUs if the aggregate operating of all fuel burning appliances is installed in space, right? So confined space was less than 50. He's telling me, hey, give me at least 50 and we're okay. Agreed? So do you agree if the room's big enough, we're done? I don't talk to either one of those guys. But do you agree if I can't give him 50 cubic foot per 1,000, then that means I can't satisfy him, so I've got to satisfy one of these two guys. I either got to cut a hole on an inside wall or cut a hole on an outside wall. And never both, and never all three. If the room's big enough, fire it up. Don't cut any holes at all. If we're not big enough, move on from him completely. Do you want to cut a hole on the inside or the outside and only talk to one of those guys only? Right? You'll see why I'm being so picky in a minute. We've talked about this all day, paying attention to context, but you'll see why I'm being so picky here. Look up here. If I've got a room with 350,000 BTUs of equipment in it, how many cubic foot of air do I need? So look at me. If I tell this guy, hey dude, how big of a room do I need if I've got 350,000 BTUs? Do you agree his simple answer is going to be, I don't know.
350.
But you got to have 50 for every 1,000. Agreed? That's all he knows. That's his only rule. So basically he's going to say, Wade, how many times do you have 1,000 BTUs? Do you agree? I've got 1,000 BTUs 350 times. So he's going to respond and say, okay, Wade, you need 50 cubic foot 350 times. So 350 times 50 is 17,500 cubic foot of space. If the room is 17,500 cubic foot, fire it up. You're good to go. But do you agree if the room is 17,499 cubic foot, we didn't make it. We got to cut a hole now.
Yep.
Now, just so you know, if we didn't make it, we have to cut a hole. And you need to know that the hole you cut has to meet the full requirement of the hole. Meaning, if we were 17,499, we don't just need to cut a little hole. Whatever size hole he tells me, I got to cut the entire volume of the hole because I didn't make it. I can't just cut a little hole to make up the difference. I either made it or I didn't. If I didn't make it, I got to do the full rule or the full rule for an indoor opening or an outdoor opening. Make sense? Now, just so you know, you and I, we look at this and go, gosh, wouldn't you eventually burn the air out of the room? We don't know. The code says, hey, if you give me 50 cubic foot per 1,000, we're good. Just so you know, that means they've already calculated that's enough air to burn the fuel and continue to burn the fuel and continue to exhaust and still be okay. It's not just enough to do it. It's enough to do it and safely continue to do it. So again, do we agree if the room's big enough, we're done? Move on. Don't read anything else. But if the room's not big enough, do you agree now we got to follow 701.5 or 701.6? Still not both, but either one. Agreed? Let's move on to 701.5, middle right. 701.5 is indoor opening size and locations. It says openings used to connect indoor spaces shall be sized and located in accordance with the following. Number one, combining spaces on the same story. Each opening shall have a minimum free area of 1 square inch per 1,000 BTUs of the total rating of the appliances in the space. I'm going to stop there. Now I told you not to stop in the middle, but there's two separate rules. So I want to stop. We'll talk about one rule, then we'll move on to the other. So first off, that vertical line, in 2003, the code said when combining space on the same story. In 2012, 15, and 18, they took that out. They just said equipment, each opening shall have a free area. That's where they started. They left that first sentence out in the last 3 or 4 code cycles. So again, now they put it back. So do you agree if I cut a hole in that wall, I'm combining space on the same story? But number 2, again, this should be a vertical line all the way beside it because it's been gone for years. Number 2 says when combining space on additional stories. Do you agree if I've got a sealed attic and I cut a hole in the ceiling, do you agree I'm still getting my air from inside the building? Now listen, I said a sealed attic. Do you agree if it was a vented attic, then it would be outdoors or spaces freely communicating with the outdoors? Make sense? So again, that's why 1 and 2 are there. They took 2 away for years, they put it back in. They just said, hey, each opening has to be this big. Now they're saying, hey, if you're combining on the same story, otherwise if you're combining on additional stories, you got a different rule. Okay? It says, each opening shall have an area not less than 1 square inch per 1,000 BTUs of the total and per rating of appliances in the enclosure. So I'm just going to reach into thin air and make up a number, 50,000 BTUs. I just made that up. Do you agree the code just said, hey, wait, I need 1 square inch for every 1,000. Do you agree I've got 50,000, so I need 50 square inches of area? By the way, pay attention to the first word of that second sentence, each opening. Second row guy hasn't told me how many holes to cut yet on an inside wall, but he said, hey, Wade, however many holes I tell you to cut, each of them have to be this big. Do you agree so far, 1 square inch per 1,000, I got to cut a 50 square inch hole each. Agreed? Now keep reading. Fourth line down, but not less than 100 square inches. So do you agree my 50 square inch hole now is not sufficient? It's got to be at least 100. Now I explain it this way on purpose, and sometimes people say, Wade, why did you say 50 square inches when you knew it was going to have to be 100 square inches? Because look up here. What if I back up to this? What if I've got 350,000 BTUs of equipment in the room and the room's not big enough? Do you agree now I've got to cut a 350 square inch hole each? Agreed? So the first rule said, give me at least 1 square inch per 1,000. The second part of the rule said, by the way, never less than 100, but I still need at least 1 square inch per 1,000 BTUs. So do you agree in this case I'd have to have a 350 square inch hole? Does that make sense? So we're going to see this more tomorrow in the plumbing code. There's not a lot of references in the mechanical code, more in the plumbing code. But when the code gives you more than one rule, do you agree you got to follow both rules? So basically what the code is saying is, I want at least 1 square inch for every 1,000 BTUs, and I also want at least 100 square inches. So backing up, Wade made up 50,000 BTUs. Do you agree a 50 square inch hole meets the 1 square inch per 1,000, but it broke the minimum 100 square inch rule? So do you agree I got to be at least 100 square inches? Now look at this. If I meet the 100 square inch rule, do you agree that beats both rules? It gave me at least my 100 and at least my 50, right? So again, two ways to think about this. You got to meet both rules, or the greater rule will automatically meet the lesser rule. Now, what about the 350,000 BTUs? Do you agree now I got to have a 350 square inch hole? People get in trouble here because they go, no, you got to be at least 100. Okay, I do need to be at least 100, but I still need my 1 square inch per 1,000. So to agree now my 1 square inch per 1,000 asking for a 350 square inch hole, my 100 square inch hole rule is not going to meet now. Now I need a 350 square inch hole. Look at me. Do you agree that 350 square inches meets that 100 minimum? So do you see how that met both rules? So the greater rule will automatically meet itself and the lesser rule. But the code says I want both of these. I want 1 square inch per 1,000, and I want at least 100 square inches, and I want them both. Okay. Next sentence says, one opening shall commence within 12 inches of the top. One opening shall commence within 12 inches of the bottom of the enclosure. So now the second row guy, I'm still talking to the second row guy, indoor opening, he told me how many holes I needed to cut. Hey, wait on that wall behind everybody, because on the other side of that wall is still the indoors. I need you to cut one hole starting within 12 inches of the top, another one starting within 12 inches of the bottom. They use the word commencing. To commence, start, or begin, that's all the same thing, right? So that means the entire hole doesn't have to be up there, but the hole has to start up there. Does that make sense? Everybody look up here on the wall. This is not true, but we're going to assume this aluminum frame is 12 inches off the ceiling. We know that's not true, but just play along. If from here, this aluminum frame to the ceiling is 12 inches, do you agree this hole is okay? Do you agree that hole commences in the upper 12? Now again, we're talking about the wall behind you. We're just looking here so we can see it. Look again. Is this okay? Do you agree the hole did commence in the upper 12? Agreed? It didn't stay up there, but it started up there. That's okay. One more time, watch this. Do you agree some of that was up there? That's still okay. One last time, look at this. Do you agree this is not okay? Because none of this is in the upper 12. Make sense? This is okay, this is okay, this is okay, this is not okay. By the way, that's one. Now I need another one in the bottom. Now the other mistake people make is, let's use our 350 square inch example. The next mistake people make is they divide it by 2. That's 175 square inches. 175 in the top, 175 in the bottom. Do you agree that second sentence, first word said each opening? That means I need 350 in the top if I need 350. And I need another 350 in the bottom if I need 350. Or if the 100 square inch would meet both rules, I need 100 in the top and I need another 100 in the bottom. Each opening has to be that big. Make sense? Last sentence in that paragraph, the minimum dimension of air openings shall not be less than 3 inches. So the only change in there is they refer you to figure 701.5 on the next to the last line. The last line they said 76 millimeters. That metric measure has never been in the code before. That's the only change there, right? Still 3 inches in dimension. Now listen guys, now I'm confused because I was okay with 100 square inches. I was okay with 1 square inch per 1,000, but now you're telling me got to be 3 inches. Now again, pay attention to the second word. The what?
Minimum.
Dimension. So do you agree? All they're saying is this combustion air duct, the smallest dimension can never be smaller than what? 3 inches. So again, I'm just making this up, 100 square inches. Do you agree a 2 by 50 will give you 100 square inches, but you're not allowed to do it because this dimension's less than 3? How about a 3 by 33 and a half? That's 100 and a half square inches. Do you agree that's okay? Because the minimum dimension was at least 3, and you gave me at least my 100 square inches. Make sense? A 4 by 25, a 10 by 10, right? A 12-inch round, whatever, right? So now why did I say a 12-inch round? Because if I still need that 100 square inches, do you agree a 3-inch round will meet my minimum 3 inches in dimension, but it's not going to give me my 100 square inches of area. Make sense? You guys okay with that? Now remember, look at me again. If the room is big enough, we should have not read any of that. If the room is not big enough, we want to talk to him, but only if we're going to cut a hole on an inside wall. Do you agree if I want to cut a hole on an outside wall, I should not have read a word of this. I should have gone straight to 701.6. Make sense? You'll see why I'm making such a big deal about this in a minute. Let's move on to 701.6. Very last 2 lines, it says, outdoor combustion air shall be provided through openings to the outdoors or spaces that freely communicate with the outdoors. It says to the outdoors in accordance with section 701.61 or 701.62. The minimum dimension of air openings not be less than 3 inches. By the way, let me correct that. I told you the change previously was the table in the millimeters. The code actually cleaned this up because it used to say the dimension. But they clarified here. Which dimension? The minimum. It said that back in 701.5 and 701.6. So that's your vertical line change here. It used to say the dimension shall be not less than 3 inches. Now they're saying the minimum dimension not less than 3 inches. That's a little cleaner. Okay? We don't care about the other dimension. We only care about the minimum one. Now let me ask you something. Did you already know that? And the answer is no. Now listen, I'm going to give you my smart aleck alert, right? This is going to sound smart aleck. I don't mean it smart aleck. I'm trying to prove a point to you. So I'm trying to be precise, not trying to be smart aleck. Do you agree this guy did not tell me that about this guy? He told me that about himself. So do you agree when we read that now, do you agree this is new information? Because now this is the first rule we've heard about an outdoor opening. Now let me ask the question a different way. Is that the same rule the indoor opening guy gave me? Yes. But I asked you, did you already know that? And the answer is no, because do you agree you shouldn't have read 701.5 if you were working on a 701.6? Make sense? So again, this is not a repeat. This is a new piece of information for an outdoor opening. Okay? Now let's keep going. Down below that, 701.6. Dot 1, 2 permanent opening methods. 2 permanent openings. 1 commencing with a 12 inch to the top. 1 commencing with a 12 inch bottom enclosure shall be provided. Let me ask you again. Did you already know that? And the answer is no. We didn't know that about an outdoor opening till just now. Let me change the question and ask it a different way. Is that the same rule as an indoor opening? Yes. But we didn't know that until now about an outdoor opening. Now listen guys, the reason I'm being so picky with you, those 2 rules are the same. Minimum dimension at least 3 inches. I need a hole within 12 of the top and a hole within 12 of the bottom. And then the rules, nothing else agrees. But the problem is because those first 2 rules are the same, people say, oh, they're all the same. They're absolutely not the same. These are the only 2 rules that are the same. 3 inches in dimension and 12 of the top, 12 of the bottom. Look what it says. The opening shall communicate directly or by ducts with the outdoors or spaces freely communicating with the outdoors as follows. So before we go on, we all know what the outdoors is, right? That's just outside. Give me an example of a space that freely communicates with the outdoors but is not outdoors. What kind of attic? A vented attic, right? What kind of crawl space? A vented crawl space. Because remember, if that attic was sealed, do you agree now we're back to 701.5 indoor openings? Make sense? But if it's a vented attic, do you agree 100% of the air in the vented attic comes from outside? Agreed? So it's not outside, but it freely communicates with the outside. I use the example stink. If their outside stinks, what does the air in the vented attic smell like? It stinks. If the air outside stinks, what does air in a vented crawl space smell like? It stinks, right? Because it's the same air as outside, right? So we got to communicate by ducts or direct communication. So let's talk about that. If I've got a duct going through the ceiling, you can see my duct. If I've got a duct going through the wall, you can see my duct. But do you agree if I take that door over there off the hinges, you don't see any duct work, do you? That would be an example of freely communicating with the outdoors or freely communicating with a space that communicates with the outdoors. So if I were to push the ceiling tile out and above the ceiling I had a vented attic, do you agree that's direct communication again? Again, there's no duct unless you can see the duct. That's a vertical duct because I can see it. That's a horizontal duct and I can see it. If I push the ceiling tile out, that's direct communication. If I just cut a hole in the floor, that's direct communication. If I just take the door off the hinges, that's direct communication. Okay? Down below that, dot 1, 2 permanent opening methods. Down below that, number 1, we're directly communicating with the outdoors. So I took the door off the hinges or pushed the ceiling tile out of the vented attic. Or we're communicating the outdoors through vertical ducts, either one. Notice what it says. Each opening. How many openings did it already tell me I had to have? 2, one with a 12 at the top, one with a 12 at the bottom. Each of those 2 openings shall have a minimum free area of 1 square inch per 4,000 BTUs of the total input rating of appliances in the enclosure. That means I don't care if you have 1, I'm just going to make up a number, 800,000 BTUs. I just made that up. I don't care whether you have 1 appliance worth 800,000 or 2 400,000 BTU appliances or 8 200,000 BTU appliances. 4 of those, sorry. Do you agree that's 800,000 however you got it? Whether it's 1 or 2 or 5, add it all together, my total is 800,000. So do you agree the code says, hey, if you're a vertical duct or we're directly communicating with the outdoors, that'd be taking the door off the hinges, pushing the ceiling tile out, cutting a hole in the floor, I need 1 square inch per 4,000 BTUs. So I would take my 800,000 divided by 4,000, that's 200 square inches of area. Each, right? So on this wall, if I'm going to run a vertical duct into the vented attic or through the attic to the outdoors, do you agree that vertical duct has to be at least 200 square inches of area? If I'm going to take the door off the hinges, that's direct communication, that's at least 200 square inches of area. Do you agree I need 2 vertical ducts, one commencing within 12 inches of the top, another one commencing within 12 inches of the bottom of the enclosure? Does that make sense? So each of those ducts have to be at least that 200 square inches of area. Does that make sense? Mm-hmm. Now, we're done talking about direct communication vertical ducts. Number 2, down below there, what's the difference? Number 1 was vertical duct or direct communication. Down below that, number 2, what is that? Horizontal ducts. So it says, number 2, we're communicating the outdoors through horizontal ducts. Each opening shall have a free area of not less than 1 square inch per 2,000 BTUs of the total input rating of appliance in the enclosure. We're going to use that same number, 800,000 divided by 2,000. Do you agree now I need 400 square inches of area? Agreed? Each on a horizontal duct. Show you a couple of pictures. So, if I've got this house here, and this is my mechanical room, and I've got a vented attic, because Wade said so, otherwise we wouldn't know. So it's a vented attic, there's some kind of hole in there to ventilate that. And I've got my equipment in this room, and it's venting straight out, that's my exhaust. Do you agree this vertical duct, one within 12 of the top, one within 12 of the bottom of the enclosure? Agreed? So on this 800,000 BTUs, I would divide that by 4,000 BTUs if it's a vertical duct or direct communication. Right? So 800,000 divided by 4,000, that's 200. I've got 4,000 BTUs 200 times, so I need 1 square inch 200 times. So this hole needs to be 200 square inches of area. This hole needs to be 200 square inches of area. Look up here. Do you agree if I cut a hole right there in the ceiling, that's directly communicating with the outdoors or spaces that freely communicate with the outdoors, right? This isn't outdoors, but it does freely communicate. Now I'm just going to put these lines here so you can see it. This is just a hole in the ceiling. Do you agree that hole better be 200 square inches? Yes. Now I'm pier and beam construction with a vented crawl space, and I cut a hole right here in the floor, I'm just putting these lines so you can see it. Do you agree that needs to be 200 square inches of area? Look up here. If I'm going to cut a hole in the wall, first off, do you agree this hole has to commence within the upper 12, and that hole needs to be 200 square inches. If I cut a hole in the bottom, that hole has to be 200 square inches. Now, we don't need all of these. We need two of them. We need one in the top and one in the bottom. So look, do you agree I can do this and this? Look up here. I can do this and this. Agreed? Because this is a vertical duct, this direct communication, so that's what size they need to be. But do you agree I have to have one in the top and one in the bottom? Look up here. Do you agree I cannot do this and this?
Yeah.
Because those are both in the top. Either one of those are fine, but I also need one in the bottom. So this and this are okay, this and this are okay, this and this are okay. This and this is okay, this and this is okay, this and this is okay. But I got to have one in the top, one in the bottom. You guys okay with that? Now, do you agree every one of those things I just showed you is either a vertical duct or direct communication to the outdoors or spaces that freely communicate without the outdoors, like a vented attic or a vented crawl space? You guys okay with that? Now, I'm going to change colors here. What if I've got a horizontal duct running through this exterior wall? First off, I need one within 12 of the top, one within 12 of the bottom. But for horizontal ducts, they said I need 1 square inch per 2,000. So now my 800,000 BTUs divided by 2,000 is now 400 square inches of area. So do you agree this horizontal duct needs to be 400 square inches, and this horizontal duct needs to be 400 square inches of area? Agreed?
Yep.
Now, let me ask you this. Everybody look up here. Can I do this and this?
No.
Sure. Well, these are different. Yeah, well, this one's sized the way horizontals are supposed to be sized. This one's sized the way direct communication are supposed to be sized. That's okay. I can do this and this, or 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 this and this, and this and this, right? I just have to have one in the lower, one in the upper. And again, it's okay to do these because this is horizontal, so I'm sizing it as a horizontal. This is vertical, so I'm sizing it as a vertical. Now, this is going to bite me in the butt here in a minute, but basic physics, what does hot air want to do?
Rise.
It wants to rise. What does cold air want to do? It wants to fall. So do you agree these vertical ducts, air naturally wants to move vertically? Do you agree you can get air as hot as you want and it'll never go right?
Yeah.
You can get air as cold as you want, it'll never go left. Right? Air doesn't want to move this way. So does it make sense to you these horizontals need to be bigger than the verticals to move the same volume of air? Does that make sense?
Yep.
That's the logic behind that. Okay. If I'm going to put a horizontal duct, it needs to be bigger because air doesn't want to move this way. If I put a vertical duct, air wants to move that way already. I just need to give it a place to go. That make sense? All right. Now, I'm going to give you a couple of notes, and then I'm going to give you a couple of practice questions to work out. But I call these the steps for sizing combustion air. Now, you don't need to write this down, but if you do, please don't abbreviate anything. If you abbreviate this, you're going to look back later and go, these are the steps for sizing California, and it's not going to make any sense to you, right? So spell out combustion air if you write this down. By the way, what do you think step number 1 is? The very first thing to consider is, look at me, what if the room's big enough? I don't even need combustion air. Agreed? So step number 1, or question number 1 is, do I need combustion air? And again, don't abbreviate that, spell it out. So do you agree if my room is 50 cubic foot per 1,000, I don't need it? Agreed? Done. Step number 2, from where? In other words, where am I getting my combustion air from? Look up here, guys. Can I get it from in the room? Right? By the way, I'm going to change that. Can I get it from indoors? Yep. Can I get it from an indoor opening? Can I get it from an outdoor opening? Now, everybody look up here. Watch this. I'm going to mark that one out. The reason I'm going to mark that out is because if the room was big enough, I would have never gotten to step 2. Make sense? If I'm going to get it from right here indoors, right here in this room, then I would have never gone to step 2. Room's big enough, you're done. If you need it, where am I getting it from? Do you agree? I either got to cut a hole on an indoor or cut a hole on an outdoor. Make sense? And then number 3, how am I getting it? Am I a vertical duct? Am I a direct communication? Or am I a horizontal duct? Now again, you notice I put those 2 on the same line because that's both number 1 and this is number 2. Whether you're a vertical duct or directly communicating with the outdoors, that's 701.6.1 number 1. Horizontal duct, 701.6.1 number 2. Now, basically, do you agree all I wrote up here on the board was only talk to the guy you need to talk to? If the room's big enough, don't talk to anybody else. If the room's not big enough, hold on, am I going indoor or outdoor? Once I figure that out, only talk to that one guy, not the other. Does that make sense? This is a way for you to systematically work through this section. Okay? All right, look up here on the board. I'm going to give you a copy of this, so don't write this down. I just want to talk to you, and then I'm going to give you a copy and let you work it out. So first off, let me just read these to you. A building has a mechanical room with 4 boilers. Half of the boilers are 250,000 BTUs each. The other half are 600,000 BTUs each. What size are the 2 square vertical ducts required to be from the vented attic? So do you agree right there? I don't know the size of the room, so I can't figure out if I've got my 50 cubic foot per thousand. So I got to go into sizing it. Am I an indoor or an outdoor opening? I'm outdoors, right? Because it's a vented attic. That's a space that freely communicates with the outdoors. So that takes me to 701.6 outdoors. And then they said it's a vertical duct, so you'd agree that takes me 701.6. This takes me number 1, right? Vertical duct or direct communications. Does that make sense? So again, you see how everything else went away except for that. Now again, I'm going to give you a copy of this, so don't write it down. We're just talking right now. Let's jump into question number 2. I've got a confined boiler room with 3 750,000 B2 boilers. It's equipped with 2 square vertical ducts into the vented attic. So do you agree I'm still outdoors or spaces that freely communicate with the outdoors? So I'm 701.6, right? I am a vertical, right? So that's 701.6, number 2, right? I'm sorry, number 1, vertical. Now, number 3, a 2 square horizontal ducts are run through the exterior walls to the outside to supply combustion air to a 5,000 B2 boiler. What size must the 2 square horizontal ducts be? So now that we're horizontal, do you agree we're still going outdoors? And down below that, number 2, because we're horizontal. Do you agree we'd add all these BTUs together in number 1, work it out for that? Secondly, we'd add all the BTUs for number 2, right? Get the total BTUs, and then that's what we work. Make sense? All right, guys. Let's walk through this. So I may be rushing you a little bit on this, but in reality, this stuff is fairly straightforward. So if you're only reading what you should be reading, only following the rules you should be following, then you should be done. Otherwise, you could sit here and spin your wheels on this for a while, kind of lost with where you need to go. So we're going to work these out one at a time. Now, I'm going to ask you a favor, and that is please don't copy down my solutions. I'm going to give you a copy. Anybody who wants one, I'll give you a copy of this with the solutions. The only reason I ask you not to write them down is I want you to listen and not be busy writing. I'll give you a copy of everything you're about to see. Okay? So already got them printed, ready for you up here. Anybody that wants them, you're welcome to have one. But listen, don't worry about writing it down. Okay? So first off, we've got a building has a mechanical room with 4 boilers. Half the boilers are 250,000 BTUs each. The other half are 600,000 BTUs each. What size are the 2 square vertical ducts required to be from the vented attic? Again, we need to read the whole question. That way we've got all the data put together. So I'm going to add those together. 250 plus 250 plus 600 plus 600 is 1,700,000 BTUs. So the rule is on the total volume, right? So 1,700,000 BTUs. And then I'm going to divide that by what? Why 4,000?
Because it's
Because it's a vertical duct. 701.6, dot 1, right? 2 openings. Number 1 below that, vertical ducts, 1 square inch per 4,000 BTUs. So, 1,700,000 BTUs divided by 4,000, that gives me 525 square inches of area. Probably need to change that color because if your eyes are like my eyes, they're darting all over the place with trying to read that red. Sorry. 425 square inches of area. Is that right? Now, just so you know, that's true, but that's not the answer. So how can I say that's true, but that's not the answer? Read the last line again. What does it say? What size? Right? So it doesn't want to know the area. This is the area I need, but they want to know what size is it. So again, the question said square. So do you agree this is a 24 by 20? A 21 by 21. Now, 2 things. If you were in the real world, everybody grab your cell phones. I want you to go to your calculator, and I want you to type in 425 square inches, just 425. Right? Now everybody look at me. If your phone is unlocked and you turn it sideways, that'll give you a scientific calculator. So on your scientific calculator, whether you're a iPhone or an Android, whatever, you're going to see something that either looks like this. The one in my phone looks like this with a number 2 there. That's the square root. So I got that 425 in there. Now push that square root button. That gives me a 20.6155, whatever. So do you agree that's a little over a 21, a little over a 20? So do you agree that's a 21 by 21? Now on the exam, they will provide you with a calculator. They won't let you take your cell phone in. They won't let you use your own calculator. They'll provide you with one. But their calculator will have square root button. You just hit the square root button. It'll tell you this is a 20 and change. So do you agree I got to be at least 21 by 21? Now on the test, listen to this. On the test, do you agree you could just check the 4 choices? I'm just going to make this up, a 10 by 10, a 20 by 20, a 30 by 30, or a 40 by 40. Do you agree? Just check the 4 choices. 10 times 10 is 100. That's not big enough. I need 425. 20 by 20 is 400. Close, but didn't make it. 30 by 30, that's 900. That'll work. Do you agree? A 20 by 20 is too small, so it have to be a 30 by 30. Out of those choices. Do you agree I don't need to check a 40 by 40 because a 30 by 30 is sufficient? Does that make sense? Wouldn't be any harder. I just may not be able to do these as fast in my head if it was a 15 by 15 or a 20 by 20 or a 25 by 25 or a 30 by 30, right? I would just work through those one at a time until one of them gave me the size I needed, right? And then how many of these 21 by 21s do I need? 2. One within 12 of the top, another one commencing within 12 inches of the bottom. Does that make sense? And again, I'll give you a copy of everything you see up here. It'll actually be able to read easier because it's in black and white on the paper I'm going to give you. Number 2, I've got a confined boiler room with 3 750,000 B2 boilers is equipped with 2 square vertical ducts into the vented attic. What minimum size must the ducts be? So, 750,000 times 3 is 2,250,000 BTUs. So 2,250,000 divided by what?
4,000.
Why 4,000? Because we're a vertical duct, right, to the outdoors. 701.6 outdoors, .1, number 1, vertical ducts. So 2,250,000 divided by 4,000 is 562.5 square inches of area. That needs to be a 24 by 24. And again, if your choices on the test are a 20 by 20 or a 21 by 21 or 23 by 23 or 25 by 25, you just work through those and see which one works, right? Again, on the test, you can just hit your square root button, whatever that is, needs to be that size or bigger, right? So, you guys okay with that? Pretty straightforward stuff, same kind of math. Now, just so you know, some of you made a careless mistake and came up with 2,250 or something like that, right? It's easy to do this in your head and make a simple mistake. So you've got a calculator, use a calculator. Okay? 350,000, 000 times 3, right? So again, we can get in trouble there, 750,000. Number 3, I've got 2 square horizontal ducts run through the exterior wall to the outside of plastic combustion air for a 5,000 B2 boiler. What size must the 2 square horizontal ducts be? So again, we don't have to add anything together. They gave me my total BTUs, 5,000 divided by what?
2,000.
Why 2,000?
Horizontal duct.
Because it's horizontal. 5,000 divided by 2,000 is 2.5. So do you agree a 2 by 2 will give you 2.5 square inches of area?
Okay.
Yes, it will. That'll give you 4 square inches. That's more than you need, right? So do you agree it will give you enough area? But what's wrong? You're not allowed.
It's not 3 inches.
You got to be at least 3 inches. Now let me ask you again. We're talking to the third row guy. Did the third row guy say that had to be 3 inches? Yes, both of them did. Okay? So now, do you agree a 2 by 2 will give you enough area? You're just not allowed to install it. So do you agree you got to install a 3 by 3? So again, do you agree if this was a test question, 2 by 2 would be wrong because you're not allowed. So the answer would be a 3 by 3. Agreed? So simply because that's the minimum size of the combustion air duct. It's got to be at least a 3. Hey guys, quick question. I thought you had to be 100 square inches. So a 3 by 3 is only going to give you 9 square inches. I thought you had to be 100 square inches. And the answer is no, because the third row guy never said that. This guy did. Again, do you see why it's so important to pay attention to what you're reading? Do you agree if you would have talked to him and never talked to this guy, do you agree that minimum 100 would have never even come into play? Make sense? But because we read it, now we got all that junk in our head. Now our brain's going, hold on, man, we've got to be at least 100 square inches too. No, not on an outdoor opening. 701.5 said that. 701.6 never said that. See why it's so important to pay attention to what's relevant to you. Let's go to 701.6.2. One permanent opening method. Now stop. Before you read another word, this is very important. Who are you talking to? Who are you talking to? Third row guy. Are we still talking to him? Yes, because remember he was 701.6. We're still 701.6, right? So the first rule he gave me, number 1, was 2 openings. Now, number 2, he's going to give me a different rule. Look what it says. 1 permanent opening commencing within 12 inches of the top of the enclosure shall be provided. The appliance shall have a clearance of not less than 1 inch from the sides and back and 6 inches from the front of the appliance. Then he goes on to say, the opening shall directly communicate with the outdoors or shall communicate through a vertical or horizontal ducts to the outdoors or spaces that freely communicate with the outdoors and shall have a minimum free area of the following. And then down below that, actually top of the next column, it says not less than 1 square inch per 3,000 BTUs nor less than the sum of the area of the draft hoods connected to in the equipment enclosure. Now listen guys, just give me a little leeway here. I'm going to make some stuff up. Okay? I'm just using an example here. But what did I tell you? If you know how to use the code, you're going to find times where you could save money or make more money or pass inspection or defend what you did or whatever. So let me give you an example of how you can make a little bit more money if you're paying attention to code. Now again, I'm just making this up. Play along. You and I just bid against each other on a 500 unit apartment complex. Every apartment's going to have its own dedicated mechanical room. It's going to have its own furnace, right? So that means we have to have 500 combustion air provisions, right? Combustion air for each mechanical room. Now let's say, again, this is the part I'm making up. Let's just assume, I'm pulling numbers out of thin air, we need an 8-inch round. I just made that up. But you're installing 2. So do you agree you need an 8-inch round here? And again, I'm just guessing. Let's call that a 2-footer. That way it'll go up into the attic above the insulation and it'll drop down into the room, right? So just round number, let's call it a 2-footer. But again, this room has 10-foot ceilings. So do you agree to get within 12 inches of the ground and to penetrate through the roof, I need a 11-foot, 12-foot duct. So let's just round that off to 14 foot. Again, I just made that up. So now look at me. I am not going to install 701.6.1. I'm going to follow 701.6.2, and I'm just going to install a single in the upper. So do you agree? I'm not even going to install this 10 or 12 foot, 8 foot duct. I'm sorry, 10 or 12 foot, 8-inch duct. I'm just going to install this one. Now again, I'm just making up numbers. I don't buy material anymore. I'm just making up numbers. Let's say that 12 foot, 8-inch round costs $10. Obviously, I don't buy material anymore, right? Because it's not $10. Let's just call it $10. Now, do you also agree that's 500 of those you didn't have to buy at $10 a piece? That's $5,000. Now, we're not done. Do you agree I paid my journeyman to cut one hole in the ceiling, and you paid your journeyman to cut 2 holes in the ceiling? Now, again, I'm just making this up. Let's say it cost an extra $10 for that guy to cut a hole in the ceiling between blades and labor and whatever, time. So now we're another $10 into that. You agree, now we're $20 into that second one alone. Does that make sense? So now $20 times 500, that's $10,000. So now listen to this. I underbid you on this job by 10 grand and still make the same profit you would have made on it. Or I underbid you by 5 grand, got the job, and made 5,000 more than you would have made on it. Or I bid it exactly the same price you did, and if I get it, I made $10,000 more on that job. Now, just so you know, some of you guys are sitting here going, Wade, I don't do apartment complexes. You're missing the whole point here. Do you agree if you don't do apartment complexes, at some point you're going to do your 500th house, right? So on your 500th house, now that's added up to $10,000 over time, right? You saved your material, you saved, right? Not only that, this is one less trailer you have to buy to haul, right? 6,000 feet of duct, right? That you don't have to haul to the job site now, right? 12-foot duct 500 times, right? So, anyway, do you see how if we know to use the code? Now, I mentioned something earlier. Do you agree my method is cheaper, faster, and easier, right? Now, remember, we talked about this earlier. We don't like cheap, fast, and easy. But do you agree it's okay to be cheap, fast, and easy as long as we are also legal and safe and code compliant? I'm okay with being cheaper, faster, and easier than you if I'm still legal, safe, and code compliant. So we use those words cheap and fast. Those sound bad. Oh, that guy does cheap work, that guy whatever. And again, I'm okay with cheap as long as it's still legal, safe, and code compliant, right? We don't want to do a bad job, but I'm okay doing, by the way, my job is every bit as legal as your job.
So when they say he's cheap, they say, oh, he's following code.
There you go. Doing the worst job he can do, right? Again, let's go back to what I mentioned first thing this morning. A gentleman asked me, or after our first break, I think, he said the inspector told him that in the 21 codes, the drain lines did not have to be as big, serving 4 or 5 water closets as they used to be in the code. Again, do you agree? I'm not going to make a ton of money off of this, but when I do it 1,000 times, that $25 I save now 1,000 times later, and that's $25,000, right? So again, this adds up. And again, I'm okay putting a smaller drain line in there as long as it's still code, as long as I'm still meeting code, right? Now, just so you know, if I was plumbing my personal house, I might put a bigger drain line in there because I don't want problems for myself later. But again, legal, safe, code compliant. By the way, do you agree if those smaller pipes back up all the time, that would not be safe? Agreed? Code would not allow that. So again, they are still working the way they're supposed to work, right? So again, that would be the example of a difference between a 2.5 and a 3 or a 3 and a 4. And again, there's people out there who say, I don't even run drain lines smaller than a 5-inch residential. Well, that's overkill, but okay, if that's what you want to do, that's okay, right? You just don't have to do that. All right, let's keep going here. Page 87, bottom right, 701.10, louvers, grills, and screens. Drop down inside that paragraph 6 lines. Where the louver and grill design area are not, design and free area are not known, it shall be assumed that wood louvers will have a 25% free area and metal louvers and grills have a 75% free area. Now here's what that means. You came to a job that Wade did. Let's say those holes we cut in the wall back there, I've got a louver over that. That way there's just not a gaping hole in the wall. I'll put a louver over it. Do you agree the paperwork for those louvers Wade threw away once he installed them? So it says where the design and free area are not known. I don't know how much free air is going to pass through there. So what the code is telling you is if you don't know, the paperwork's gone, if they're wood louvers, assume 25% free area. Now again, guys, I'm just reaching into thin air, making up a number. I've got a 10 by 10, 100 square inches, right? I just made that up. But do you agree that 10 by 10, 100 square inches, if it's got a wood louver, if the paperwork's gone, then we assume that's 25% free area. That's only 25 square inches of area. Remember that guy said we had to have 100 square inches of free area. So now that we put that louver or grill on there, now if we cut a 10 by 10 hole, gave him his 100, then we cover that with a metal or wood louver, he doesn't have his 100 anymore. Right? Because it's not going to flow through there. Does it make sense to you that a wood louver is thicker, right, than a metal louver, right? That's why that has more free area on a metal than it does on a wood, right? Just takes up more space in there. 75% free area on metal louvers and grills. So that same 10 by 10 hole, I put a metal louver over it. We assume that's 75 square inches of area. Make sense? So do you agree the second row guy, if he was going to cut a hole in that wall, just an example, and he needs at least 100 square inches, do you agree if he was going to put wood louvers up there and he's got a 400 square inch hole, that when he puts that wood louver over it, that still meets that minimum 25% free, that'd be 25% of his 400, that'd give him 100 square inches of free area. Make sense? Down below that, minimum screen mesh size. Screen shall not be smaller than 1/4 of an inch mesh. So look up here. On these vented attics and these vented crawl spaces, it's common for the builder to put mesh over that to keep the bugs, bats, rats, and squirrels out. So what the code is telling us, because we're getting our combustion air from there, that screen mesh cannot be any smaller than what? 1/4 inch. That means 1/4 inch at least by 1/4 inch at least. Now, what if I were to put window screen on those things? Do you agree window screens would get clogged? It'd stop the airflow. Now I don't have combustion air. Now I'm creating carbon monoxide, right? They're saying a 1/4 inch by 1/4 inch. That's going to be less likely to get clogged, more likely to let the air flow, so nothing smaller than that. And again, I could get bigger than that, I just couldn't get smaller than that. Page 88, top left, 701.11, combustion air ducts. Number 1 says they've got to be metal. I'm looking for the exception. Within dwelling units, unobstructed stud and joist spaces shall not be prohibited from conveying combustion air provided that not more than one fire block is removed. So do you agree inside this wall right here, I've got studs on edge and I've got sheathing on the front and the back? Now first off, if this wall is full of insulation, do you agree it's obstructed? Right? Can't do anything with it. But if there's no insulation in here, for example, then I could take that one fire stop out. I could take my top plate off, let the air come in, let it come in here, cut a hole in the floor. That could be my lower. Now listen, if I do that here for my lower, if I want to do the same thing in the upper, I've got to jump a chase cavity, right? Yep. Cut a hole in the top. That would be my upper. Next chase cavity or another chase cavity, that could be my lower. Do you see why you can't cut a hole in the top and bottom of the same chase cavity? What did we talk about? Hot air rises, cold air falls. So we didn't finish explaining the physics beyond that, but we talked about air wants to move vertically. But just so you know, that's why the code recommends generally, and for years did not give an option for a single. That's why they want an upper and a lower. Because do you agree when that hot air rises, it creates a static pressure on the ceiling, pushing on the ceiling, which pushes the air out the upper, which creates a vacuum in the room, pulling the air in the lowers. And then when it's cold in here, that cold air settles, creating a static pressure on the floor, pushing that air out the lower, creating a vacuum in the room, pulling the air in the upper. Does that make sense? So again, if I had a hole in the top and bottom, do you agree just recirculate the same air theoretically? Right? But by doing two, I'm pushing out here, pulling in there, pushing out here, pulling in there. Right? Down below that, highlight number 5. Ducts shall not be screened where terminating an attic. So the first thing I want to clarify is, do you agree the code did not say don't screen combustion air ducts? Did not say that. It said don't screen the specific combustion air duct that terminates where? Look up here. Do you agree I've got 2 combustion air ducts on that illustration that terminate in the attic? None of the rest of them. So do you agree I can screen those other ducts? Code doesn't say I can't. It just says you can't screen those that terminate in the attic. Now I'm going to explain something to you to help you understand it. And again, I want to warn you, this sounds like a smart aleck thing to say. It's not. I'm just trying to prove something to you. Why are you not allowed to screen a combustion air duct that terminates in the attic? And the answer is because the book said so. Now I told you that sounds like a smart aleck response. I didn't mean it smart aleckly, but do you agree that's the truth? Let me ask you again. Do you agree we really don't know why you can't screen a combustion air duct in the attic? Now by the way, you smart guys, if you go, hold on Wade, I know why, I would say show me why. The book, it's not in the book saying why. It just says do it. Do you agree? Now, I can make up some good sounding stuff. This is just Wade talking. This is not the code. Well, it makes a good idea not to screen that combustion air duct because if the insulation guy comes in behind you and blows insulation, he's going to bury that combustion air duct on top of that screen. Now you don't have any airflow. By the way, I agree, but they didn't say that with attics with blown insulation. They said, don't screen a combustion air duct that terminates in an attic. We don't care. Let me give you another example. Let's say I have storage up in the attic, and I go up in there. I take my Yeti with me everywhere I go, so I go up in the attic, and I set that Yeti on that wire mesh. Do you agree I just lost that much area of free flow of air? Does that make sense? The bottom of that Yeti. And then if I leave it up there and forget it, I come down forever, that hole is that much smaller now. Does that make sense? I pull a picture out and I lay it down on that, right? Now again, take the mesh off. Do you agree if I set my cup on that, whoop, right? All the way to the bottom, but it's still clear, isn't it? Right? So anyway, and again, I want to be clear. That's me making stuff up. Do you agree we don't know why? By the way, those sound like pretty good reasons, but we don't know why. You just can't. Right? Number 8. Combustion air intake openings located on the exterior of the building shall have the lowest side of the combustion air intake opening located at least 12 inches vertically from the adjoining finished ground level. Look up here, guys. This is specifically this horizontal and specifically the lower. They're saying, hey, this thing has to be at least how far off the ground? 12 inches. Why? Because they said so. Do you agree? We really don't know why. I've had guys in the class over the years go, well, Wade, that's for snow drift. Well, aren't there places that get 6 foot of snow drift? Right? That doesn't fix that. Well, that's for rain. Okay. Right? Whatever. There's places that gets, 18 inches of rain, right? What about that? So again, do you agree we know we're supposed to be at least that far off the ground, even though we don't know why? But again, you see how easier it is to just allow this information to be information as long as we're not trying to fight against it? Well, hold on. How come it's got to be 12 inches off the ground, right? Well, you're never going to find an answer to that because the code doesn't tell you. The code just says, because I said so. But if you look at it and go, hey, these have to be 12 inches off the ground, now your life's just easy, isn't it? Number 7. Horizontal upper combustion air intakes or air ducts shall not slope downward toward the source of combustion air. Now look, guys, we're talking about the upper horizontal now. Now, remind me what we learned from physics. Hot air wants to do what?
Rise.
So now look at me. I am sticking through this wall right here to the exterior, and I'm sloped like this, right? Do you agree when that hot air rises in here, it is not going to go down to ventilate or exhaust through this thing? Do you agree? This would work, wouldn't it? This is about level. This would even be okay, wouldn't it? Didn't say it had to be level, said it can't slope down specifically toward the source of my combustion air. Do you agree that hot air would flow through here and the hot air would flow through there, but it would not flow through there? Does it make sense? By the way, notice this is only the upper, not the lower. Okay. Again, I can explain to you based on physics why, but do you agree the code doesn't tell me why, it just said don't do it. Don't do this. You can do this, you can do this, just don't do this. My favorite paragraph in the whole code book, I think. 701.12, dampers prohibited. Second sentence. Manually operated dampers shall not be installed in combustion air openings. The reason this is one of my favorite things in the code book is because every time I read that, my brain says, who's stupid enough to close a manual damper in a combustion air duct? By the way, just so you know, I'm using the wrong word. I shouldn't use the word stupid. The more appropriate word would be ignorant. Now, when I say that, people snicker and laugh. It's not a joke. Do you understand the difference between stupid and ignorant? You Ron White fans in the room, you can't fix stupid, right? Stupid people are just stupid. The good thing about stupid people is they're stupid, so they're so stupid they don't know they're stupid, so it doesn't bother them to be stupid because they're stupid. But do you agree they drive the rest of us insane because they're stupid? Now let's change the word. Let's talk about ignorant. I've got laces on my boots here. Was there a time in my life where I did not know how to tie shoes? Yeah. Was I stupid? No. I was ignorant. Agreed? Nobody had taught me how to tie shoes yet. I wasn't stupid. I was just uneducated, uninformed, unlearned. I didn't know, right? By the way, you proud of me? I tied those by myself, all by myself this morning, right? I didn't have to say the bunny goes around the tree and pokes his head through the hole, right? That's what I had to do when I was 3 or 4, whatever. But again, I've done that so many times, right? Now we know. So now I'm not ignorant. So the reason the code says you are not allowed to put a manual damper in a combustion air duct. First off, as the code, we trust you. We trust you to be smart enough to not close it. We don't trust homeowner Wade coming in behind you after you're done. By the way, do you agree a homeowner might be ignorant about what that combustion air duct is for, but that homeowner may also be a rocket scientist? Make sense? Maybe a brain surgeon, a lawyer, a doctor. So he's not stupid. He's not even ignorant. He's just ignorant about that. Had a friend who was a nuclear astrophysicist, right? Whenever I was a kid, the sayings were, you don't have to be a rocket scientist, right? This guy is a rocket scientist, literally. Nuclear astrophysicist. So I was in his garage one day. He was working for the Air Force. My wife and his wife were friends. And I go over to his house and I walk in the garage and he's building a computer. I do not mean assembling a computer. I mean fabricating, wiring circuits to build his own computer. That's how smart this guy was. And he said, I asked him, I said, so we got talking, I said, so what do you do? You know the guy is smart when he takes 20 minutes to explain to you what he does, and then you still have no idea what he does. Oh, okay, so what do you do? Right? 20 minutes later, okay, so what do you do? Right? So anyway, he took 20 minutes explaining to me all the jobs he had in the nuclear astrophysicist world, right? Satellite trajectory and getting satellites into orbit and the volume of fuel required to push that thing out of the outer atmosphere and why we had to use oxygen. You know why we have to use oxygen for rocket fuel? Because when you get out of the atmosphere, there's no oxygen to burn any other fuel you take with you, right? They agree your gas would stop burning when you left the atmosphere. So now you have full tank of gas, but you're not going anywhere. That's why you have to use oxygen. By the way, that's useless trivia. You're welcome, right? You can just have that for free. Anyway, so we started talking about this, and again, he did spend 20 minutes explaining to me what he did. And then when we were done, he looks at me and goes, so what do you do? Right? And I'm like, nothing. After listening to his 20-minute conversation, man, I'm like, dude, I don't think I know anything compared to all the stuff you just said. And he goes, no, he goes, what do you do really? And I said, well, I teach code and calculation and theory, combustion air sizing, that kind of thing. And he goes, hey, maybe you can help me. And he walks me over and he goes, what's this for? And it was a combustion air duct. By the way, when a nuclear astrophysicist asks you what something is for that you know, you feel really smart. I know more than a nuclear astrophysicist, right? So I walked over there and I tapped on the duct and I said, well, this duct, right? And it sounded solid, didn't sound hollow. I said, this duct, this is a combustion air duct, and as I beat on it, it sounds pretty solid, so I kind of tap on it, I stick my hand up in there and I pulled a pillow out of that combustion air duct. And I said, hey, somebody's trying to kill you. Right? They clogged up your combustion air duct. You know what my nuclear astrophysicist friend told me? He said, oh, I put that in there. I said, why did you put that in there? He said, it was cold in the garage. Fortunately for this guy, he had enough brain cells to suck some carbon monoxide for a while and still be smarter than the rest of us, right? The rest of us, we're barely making it as we go, right? We can't stand to lose any brain cells here. So anyway, when I pulled that out, I pulled it out and I said, hey, this is a combustion air duct. When I pulled that out, I mean, you could just tell he was shocked because, again, he's smart enough to understand what combustion air is. Because he understands if you don't have enough air, you can't burn the fuel. That's part of astrophysics, right? Whatever. Nuclear rocket science, whatever. So whenever I pulled that out and told him, hey, dude, somebody's trying to kill you, he kind of turned pale. Now, I guess turned a lighter shade of pale. If you know any nuclear astrophysicists, they're all pretty pale to begin with, right? They don't get outside much, right? So this guy turned a lighter shade of pale, realized what that was for. Now, I had another person, this was a client, tell me something that one of their customers said. Customer stuck a teddy bear up in their combustion air duct, and when the mechanical guy got there, the unit wouldn't stay running, right? It was starving for oxygen, flame would go out, right? So he lights it, everything's good, homeowner calls him back, flame's out, right? So he starts looking around, and then he thinks to check the combustion air ducts, right? And there's a teddy bear stuck in there, both of them, upper and lower, right? So I think there was bad insulation in one and a teddy bear in the other, he told me. But you pull those out, that way you have free flow of air, that way you don't have to burn the fuel, right? And he said, here's what the homeowner told him. He said, well, the reason I clogged that one up was because the stupid air conditioning guy had a duct that blows air into the garage that's only cold in the winter. All right, let's walk through that again. The stupid AC guy installed an air conditioning duct that only blows cold air in the winter. You mean when the furnace is on? But they didn't think that far through. Now, in all fairness, do you agree that person walked over there, I'm cold, it's colder over here, it's getting colder. Okay, here's a duct and I stick my hand under there. Do you agree if you don't know, you feel like air is blowing through there? But do you agree it's not blowing? That cold air is more dense than the warm air, so it's falling through there, agreed? But when you stick your hand in there and you feel movement, it feels like it's blowing, whether it's rising or falling. So to fix that, we just shove a teddy bear up in there to stop that cold air from blowing, right? By the way, let me ask you something. Do you agree the cold air was blowing in the winter? Do you agree that's when they needed that combustion air the most? Because not only are they still using hot water in the winter, but now they're using their furnace in the winter as well. We need combustion air now more than ever, right? That just shows you, and again, proper word, that's how ignorant those people are, right? Again, they're not stupid. My nuclear astrophysicist friend's not stupid, but he was just ignorant about that purpose. And as soon as I told him, it made perfect sense to him. Oh, that makes perfect sense why that's there, right? So, anyway, are you allowed to install a damper on combustion air ducts? Careful, careful. Are you allowed to install a damper on combustion air ducts? Yes, you are. Do you agree? This said no manual dampers. Read on down. What does the rest of it say? With prior approval, power-actuated movable louvers admitting combustion air shall be permitted to be used and where installed shall be electrically interlocked with the main burner fuel supply valve so to prevent fuel delivery unless the louver is in a fully open position. Now the reason I wanted you to hear this, again, some of you guys live in Red River and Eagle's Nest and places where it's really cold, right? So Albuquerque, not that big a deal. It gets cold here, but not that cold, right? But let's say I'm in Eagle's Nest or Cloudcroft or somewhere where it's 15 below outside. Now again, it doesn't get that cold often, but let's say it is. Do you agree that 15 below air coming into that mechanical room could freeze those pipes, right? So do you agree it's okay to have louvers to keep that air out until the unit needs to fire? Now notice what this said. You're allowed to have, as long as they're electrically interlocked with the fuel gas valve, where the fuel will not be delivered unless the louvers are in the fully open position, right? So if those louvers start moving, we're still not giving you gas. Not until they're fully open. Then we'll give you gas to fire the unit because now the louvers are open, you're breathing air in, and then when that unit shuts down, those louvers will close again, keeping that cold air out. That would be okay. And again, that might be necessary in a really cold environment to do that. But do you agree a manual louver would still be not allowed? Because I may forget to open it or forget to close it, or really they're more about me forgetting to open it than or closing it than they're worried about forgetting to close it, right? It won't hurt me if I don't close it, but it may kill me if I do close it, right? Sorry? Yeah. So now again, the theory here is, notice what this is saying. Manual operated dampers shall not be installed in combustion air openings. So whether that's an opening in that wall or an opening to the outdoors or an opening in a duct, vertical or horizontal, do you agree all those are openings? I want to show you what I just did. This is important for you to see. Whenever I heard him say that, do you notice all I did was turn around and read it again? Is it ducts? Is it outdoor? Is it indoor? Do you agree? We don't need to remember that. Let's just read it. Manual operated dampers shall not be installed in combustion air openings. That means vertical, horizontal, indoor, outdoor, no manual dampers. Because again, even that one, do you agree if somehow I climb up there and close that manual damper, do you agree I still lost all my combustion air to this room? Or that one down there, or this one up here, or this one down here, or this one, right? Doesn't matter. That's why they say any openings. The area of the opening. Well, if I want to talk about the area of the opening, wouldn't that take us back here?
4,000, 2,000.
Right? So the area of the opening would be 1 square inch per 2,000, 1 square inch per 4,000, 1 square inch per 1,000, right? That'd be the area. But remember here they say where the design and free area are not known, right? Then this rule would come into play, right? Now, this could be either one, but do you agree these louvers and grills may or may not have a damper on them? Now again, code said no manual damper, so I'd have to use a louver without a damper. I'd have to use a grill without a damper. That way Wade couldn't climb up there and close that because there's nothing to close, right? These regular air vents you run into a residential house, for example, though, a lot of those have dampers on them, so they could close those, and if that's where the air is circulating through, right, we lost that, right? So again, we'd have to go there. Now, again, I apologize. I'm deaf, so I missed your question. Sorry about that. But again, I want to show you again what I was trying to show you. Do you see how we just went back to the book? We don't care what Wade thinks. We just need to know what the book says. So when we have these questions, do you agree we right this minute know how to use the code better than 90% of the people in the world? So the fact that you know how to use the code now, I would challenge you tell me. A lot of times people ask me questions, I say, you tell me. That means you find it in the book. By the way, I don't mind telling you, I'm happy to help, but do you agree you now have the ability and the skill to do it yourself? You don't need me to find it for you, right? Happy to help, but again, just to clarify, you don't need me.